All right, so we know that we've identified what the issue is, right? That we know that underneath the algorithm that's being used for concatenation is not very efficient. It was never meant to be used in a tight loop over large strings, right? That was not the original intent. It was only a very convenient syntax, right? If from time to time you needed two strings and you needed to concatenate them, and you're done, right? But we see that that particular algorithm in a tight loop that iterates over a long list really has a poor performance. It doesn't scale well, right? That what works for something that is for a small problem doesn't really scale well for large problems. Yes, and we know that, right? That we have to take into account the size. So let's try to abstract that problem. We know that that's the specific problem. Yes, but let's try to abstract it so that perhaps we can consider different versions of the same algorithm. Right? We'll abstract it perhaps into an interface, and then that interface can look at different implementations of that same issue. Right. So the problem is that we want to solve is that we are accumulating. Right. We have an initial string, and we want to accumulate one character at a time. Right. That's what we're trying to solve. And we know that the default implementation doesn't scale very well. That particular implementation of the concatenation is only one particular way of doing it. Right? It's a specific solution to a general problem, right, of concatenating strings. Yes. So we'll define the problem in a generic way. Right. We would like to be able to concatenate an additional character. We'd like to get what the resulting string is. Right. Those are the kinds of operations we'd like to do. And C, we'll look at the existing concatenation as one specific version, right, of many different ways of doing it, right? And then we'll compare the benchmarks against them as we make different decisions of the design decisions. Yes. Right. So we'll have different versions of formatting or concatenating. And we'll look at different competing implementations and see how it performs based on different design decisions as we iterate over this particular problem. Okay. So here's a generic interface that captures the essence of the problem that we're trying to solve. Right. We have some accumulator, and it has these two particular functions or methods. Right? We could have a whole bunch of other methods, obviously, right? But these two in particular are the ones that we care about, right? That we want to optimize, right? In particular, the append, right? We have an append that you give us one character, and we'll append it to some representation of strings, yes? We'll look first at the existing solution that Java gives us out of the box, right? The simple concatenation. We'll take that as our first go at this, right? We won't be expecting any improvements, right? I'm sure that our first iteration over this will be as bad as our original solution. Yes, we'll concatenate one character at a time, so we won't be expecting any improvements our first go, right? But we'll iterate over this and say, well, how about we do this? How about we do that, right? And we make some decisions on improvements on implementing this append, right? So this is the interface, and hopefully various implementations will do better. Okay. So someone who might want to use this interface might do something like this, right? They would instantiate a particular accumulator. Well, this makes no sense, right? Because the string accumulator is an interface, right? It's not a class. So we would be instantiating some class that implements this interface. Yes. Once we instantiate it, we can then in a tight loop, just like before, right? We would like to concatenate and append an additional character, and then get back what the resulting string is. Yes. And our first implementation is going to be as bad as the original, right? But hopefully, as we iterate over that design, we'll improve. All right, so our first naive implementation. So our first naive implementation it's basically going to implement the already existing terrible non-scaling solution, right? Basically, we're just going to use the standard out-of-the-box concatenation. If we want to append a character, we're just going to use the same, right, concatenation operator that comes out of the box in Java, right? We're representing it as an empty string, and every time we call append, we're just going to append one character on the string. I mean, we know that underneath, what Java is doing is that it's throwing away the old string, right? It's creating a new one whose size is exactly one more character long. Yes? It's copying the old string and then just adding this new character at the end. That's what's happening underneath, right? And that is what we want to avoid, right? Somehow we want to avoid that you throw away something, right? And then you and then you copy over and you build a brand new one, right? And to use a new one, right? Using Elon Musk's reusable rockets, right? It's much more efficient to use something that has already flown many times and to reduce costs, right? So that's what we want to do here. Don't throw away, reuse as much as you can. So we know this is not better, right? Obviously this won't work any better than before. So we'd like to, if we run the benchmarks of this implementation versus the old one, we'll get probably the same exact shape of a curve. Even the constant factor probably the same. The shapes and the constants are the same. But now that we have an interface, right? Now that we have a generic interface, we're free to explore other implementations other than just out of the box concatenation, right? Also, the fact that they behave the same way, right, or the old out-of-the-box implementation and our implementation, gives us some measure of confidence that our interface reflects the generic problem here, right, of which the out-of-the-box solution is just one particular solution, right, that Java. So, but now we're free to explore and try out other alternatives, right?